Dear students, I am Dr. Nuzhat Gul and we'll be discussing de Broglie equation part 2. This is the link for the part 1 जहां पे हमने de Broglie wavelength lambda और mass and velocity of a particle के लिए relationship derive की, because we discussed that de Broglie made the bold assumption where he hypothesized that like photons, material particles also have a dual nature. In this lecture, we will try to find out the relationship between de Broglie wavelength and kinetic and potential energy. Let us start with kinetic energy. De Broglie wavelength और kinetic energy के बीच relationship निकालने के लिए how we will proceed. सबसे पहले हम formula लिखेंगे kinetic energy का. That's 1 by 2 mv square. Then multiplying and dividing the right hand side by m. The equation will appear like this. Then k is equal to 1 by 2 m square v square by m. But ये m square v square की जगह हम mv square भी लिख सकते हैं and that mv is equal to p, जिसका मतलब ये हो जाएगा 1 by 2 p square by m. ठीक? So by simple mathematical operations, we will find out a relationship between first momentum and kinetic energy, और फिर इसको हम substitute करेंगे in the de Broglie's equation. Right? तो हमारा final relationship जो है that is lambda is equal to h divided by square root of twice m into k, where k is the kinetic energy and m is the mass of the particle, h is Planck's constant. So this is our relationship between wavelength and kinetic energy. Next, we'll try and derive the relationship between potential energy and the wavelength. Again, when a particle moves, its potential energy is converted into kinetic energy. And according to law of conservation of energy, this kinetic energy must be equal to the potential energy. Again, multiplying both sides by m, here also and here also will multiply by m, both LHS and RHS. Equation will appear like this. Again, instead of this mv, m square we can write down mv square, that will be p square. So here we arrived at the relationship between momentum and this mass and potential energy. Substituting it again in the de Broglie's equation, we'll find out that lambda is equal to h divided by root of twice mev. Lambda is the wavelength, m is the mass of the particle, and ev is the potential energy. So we'll substitute this ev by the capital P, potential energy. So the final relationship will be lambda is equal to h divided by root of twice mp. Now, in order to understand it better, we will try to solve a numerical. Now, first of all, I will tell you that in most of the numericals, the data is given in the form of electron volts. So I will try and explain what an electron volt is. तो सबसे पहले potential energy of a charge Q that moves or is accelerated through a potential difference of V volts, that's equal to QV. Thus, if that particle is electron, its charge will be E, and if this electron is accelerated through a potential difference of 1 volt, the potential energy of the electron will be 1 electron volt. Right? So this 1 electron volt will be equal to charge of electron into 1 volt, that is joule per coulomb. So this will be 1 electron volt will finally come out to be 1.6 into 10 raised to the power minus 19 joules. एक इलेक्ट्रॉन वोल्ट का आइडिया देने के लिए I have drawn a figure. यहाँ पे इन दोनों प्लेट्स के बीच 1 volt का फर्क है, that is it's at 0 volt, this is at 1 volt, and an electron moves through this potential difference of 1 volt. The potential energy of this electron will be 1 electron volt, right? Now we will try and solve a problem. An electron is being accelerated through a potential difference of 25 kilo electron volts. Calculate the de Broglie's wavelength for the electron. Potential energy कितनी है? 25 kilo electron volts. That's 25 into 1000 or 10 raised to power 3 electron volts. और electron volt मैंने अभी आपको बताया, that's equal to charge of electron into 1 volt. That will be equal to 1.6 in 10 raised to the power minus 19 joules. Again, हमारे जो न्यूमेरिकल में क्या डेटा दिया गया है, एक तो पोटेंशियल डिफरेंस दी गई है, राइट? और निकालना क्या है हमें? लैम्डा. सो वी विल यूज द रिलेशनशिप बिटवीन लैम्डा एंड पोटेंशियल एनर्जी. सो व्हाट विल बी द रिजल्ट लाइक? पोटेंशियल एनर्जी जो इस इलेक्ट्रॉन की है, दैट इज 25 into 1000 electron volts, right? This will be 25,000 electron volt की जगह 10 into minus 19 joules. And finally, after calculations, we find out that the potential energy of this electron is 4 into 10 raised to the power minus 15. Now we will substitute this potential energy in this equation and we'll find out the wavelength lambda. Right? We have done the substitutions. H is the Planck's constant, m is the mass of the electron, and p is the potential energy that we calculated in this step. Now, de Broglie's equation and Bohr's quantization principle. According to de Broglie's concept, electron is not only a particle but has also a wave character. Thus, in order that a wave must be completely in phase, the circumference of the orbit must be an integral multiple of the wavelength. यानी अगर ये circumference जो आपको circle दिखाई दे रहा है, if this is the orbit of an electron, and according to the de Broglie's hypothesis, इस electron के साथ waves associated है, and it is mandatory that these waves must be in phase. इनको phase में होने के लिए जो ये circumference है, circumference किसके बराबर होता है? 2 pi r. That should be an integral multiple of wavelength. यानी कि कितनी wavelengths हो सकती है इसमें? ये कितनी wavelengths के बराबर हो सकता है? 1, 2, 3, 4. Any integer, that's n, into wavelength. ये 2 pi r जो है आपका, ये n lambda के बराबर हो सकता है, where n is 1, 2, 3, 4, so on and so forth. यानी कि it cannot have a fractional value. इसका value n by 2, n by 3 इस तरह से नहीं हो सकता. It has to have a integral value. तो हम क्या लिखेंगे? 2 pi r is equal to n lambda. And we know this lambda is equal to h by mv. वही हमारी de Broglie's equation है. So we will substitute it. So 2 pi r is equal to n. इस lambda की जगह हम लिखेंगे h by mv. Simple mathematical calculation से क्या हो जाएगा? mvr is equal to nh divided by 2 pi. And I'm sure most of you will be remembering something when you look at this equation. ये क्या equation है? आपको याद आ रहा है कि बोहर ने कहा था कि जो angular momentum of the electron होगा, that must have specific values, that cannot have any value. And the values must be integral multiples of h by 2 pi. So we started with de Broglie's hypothesis, यानी कि 2 pi r is equal to n lambda, and we arrived at Bohr's क्वांटाइजेशन प्रिंसिपल। सो क्या बोला बोहर ने? बोहर्स की क्वांटाइजेशन कंडीशन क्या थी? According to this Bohr's quantization condition, the angular momentum of an electron in a particular orbit is quantized. That is, it has a definite value. And जो ये value होता है is an integral multiple of h by 2 pi. This is not here nh by 2 pi. h by 2 pi का integral multiple होता है, यानी कि h by 2 pi divided by any integer. Right? So this was about de Broglie's hypothesis and its relationship with kinetic and potential energy. I hope this video was fruitful. I thank you all and request that if you like my videos, please like, share and subscribe them. Thank you.